Having access to those graphs completely change how you design your drone. Hello, this is Charles from Tech Robotics. If you're watching this, you likely recognize the importance of motor characterization, going beyond a simple datasheet to uncover the true performance. Today, I'll demonstrate how to use one of our flight stands to create an efficiency map of your motor. Let's get started. The test procedure is quite simple. We will run a simple automated test with our motor and each of the propeller, which will allow us to collect performance data across a wide range of operating points. In our case, we're mapping the performance of the AXI 8110 motor using 6 propellers ranging from 11 to 30 inches in diameter. These propellers each apply a different load to the motor, similar to how a brake dynamometer works. Once we have our data, we will load it into our Google Colab notebook, which will execute our Python code. We have made our code public, so you can use it to generate your own motor performance plots. And you can find a link to the notebook in the description. What we've done is use performance data from 5 of the propellers to generate a model. So we can use the data from the 6th propeller to test the fit. Okay, now let's jump into the results. First of all, let's have a look at the motor electrical power map. First thing is, what are we looking at here? On the horizontal axis, we have the RPM. And on the vertical axis, we have the torque. In practice, the bottom left represents the motor that's not spinning. If we are moving at the bottom along the x-axis, the horizontal axis, that represents the motor spinning at no load. On the opposite end, if we stay close to the 0 RPM range, but we move up, that represents the brake torque. It's basically if you were to hold the motor in your hand and you were to turn it on, you'd be moving along that vertical axis. On the right, you have 2 other axes. The outer one represents the amount of electrical power being used. So for example, in the top right here, we can see that our motor consumes around 426 watts of power. And then obviously bottom left, we're close to 0 because the motor is off here. The other interesting part here is that the color of the data points that were measured are representing the difference between the measured data and the prediction that our model gave us. So what we can see here is that in reality the power prediction is very accurate. On over 425 watts, there's less than 1 watt of error in both directions, which is giving us a very good accuracy. Now let's have a look at the efficiency map. First of all, what is the efficiency? The efficiency is defined by the mechanical power divided by the electrical power. The mechanical power is measured directly by the flight stand using the torque and the rotation speed, and the electrical power is also measured using voltage and current. Here what we're seeing is that the points represent the actual measurement by the flight stand, while the bands of color represent the model that was extracted from those points. The model gives us a good idea of where the maximum efficiency region occurs. So in that case here, it's between 2,500 RPM and 3,000 RPM, and between 6 and 1 Newton meters. In practice, that means that you'll want to have your drone operating in that region most of the time. If you have a drone that spends most of its time taking pictures, you want to optimize for hover as much as possible. And if you have a drone that's moving quickly, you'll generally want to optimize for cruising speed. Another thing that we have here is the error between the prediction and the measured data. This is shown in the inner scale here, and it's represented by the color of the points. And we can see that in general, we have less than 1 percentage point of error for most of the interesting region of operation. Also, as an aside, if you were to be using a smaller propeller, so for example, the propeller that's the bottom here, although your propeller itself might be very efficient, the motor is going to be operating in an efficiency range between 50 and 58%, according to the graph here. That means a lot more heat goes into the motor. Your motor will probably fail faster, and ultimately it means that you have a much higher potential for flying longer, because going from 50 to 80% efficiency, that gives you in that case more than 50% of flight time. Another thing we can see here is that the 6th propeller, which was not included, falls between the parabolas. The reason we did not include it is because we wanted a verification set. If we had included that propeller in the modeling, we could have overfitting in that case. So we wanted to make sure that we're not overfitting, and that's why we reserved that propeller for verification. However, for normal operation, you don't necessarily need to have a verification set. Having access to those graphs completely change how you design a drone. It can save you a lot of time, and it allows you to very quickly hone in to the maximum operating point and the maximum efficiency that your drone can achieve. The reason for this is that, first of all, if you have made a good propeller selection, you can very quickly know which motor is going to operate at the most efficient point. It's very simple. You simply look at the region that has the highest efficiency, and you'll want to have a motor that has the right kV, the right diameter, the right frame to have that maximum efficiency in your operating region. The other thing is that it allows you to very quickly simulate different motors and different propellers, even if you have not tested them together previously. For example, you could have tested a lot of propellers and then you get a new motor. You don't necessarily want to take that motor and test it with your 50 different propellers that you've tested in the past. So what you can do is that when you have a good motor model and a good propeller model, you can combine that and you'll know very accurately how they'll perform together. If you found this video helpful and interesting, we invite you to like and subscribe to our channel. If you have any other questions, just leave us a comment below. Thanks for watching.